Hi, now we have looked at how to find an angle of a given trigonometric ratio. We have looked at coefficients, reciprocal ratios, and how to tackle equations with more than one term. But in this course, you will see questions with two or more of these features in one equation. So now I would like to look at how we tackle more difficult trigonometric equations. We know we can use our calculators to help us find unknown angles, but you need to simplify your equation enough so that you know exactly what information to put into your calculator in order to ensure you get the correct answer. Let's look at some examples. Solve for x in the following equations. Tan 4x minus 12 degrees is equal to 1,56. Now our tan ratio is by itself. So our next step is to get the bracket by itself. And to do this, we can move tan to the right-hand side. So we get 4x minus 12 degrees is equal to tan to the negative 1 multiplied by 1,56. Now on the left, we have 4x minus 12 degrees is equal to, now we can take our calculators and we say shift tan 1,56, close the bracket, is equal to 57,339, and this rounds off to 57,34 degrees. The next step is to get 4x by itself. And to do this, we add 12 degrees to each side. So on the left, we have 4x is equal to, take our calculator, we're going to add 12 degrees, and we get 69,339, round off to two decimal places, and we get 69,34. We're almost done. We have 4x, but we want x, which means we now have to divide both sides by 4. So on the left, we now have x is equal to, take our calculator, we're going to divide our answer by 4, and we get 17,334 degrees, which rounds off to 17,33. Let's do another one. 8 cos x plus 10 degrees is equal to 5. The first step here is to get our cos ratio by itself. And to do that, we have to divide both sides by this 8. So on the left, we're now going to have cos x plus 10 degrees is equal to 5 over 8. Now we can get our bracket by itself. And we're going to move cos to the right-hand side. So on the left, we now have x plus 10 degrees is equal to cos to the negative 1 multiplied by the bracket 5 over 8. Now on the left, we have x plus 10 degrees is equal to, let's get our calculator out, clear our screen, and we're going to say shift cos multiplied by 5 divided by 8, close the bracket, is equal to 51,317. Let's round off to two decimal places, and we see that x plus 10 is equal to 51,32 degrees. Finally, to get x by itself, we subtract 10 degrees from both sides. So on the left, we now have x is equal to 51,32 degrees minus 10 leaves us with 41,32 degrees. Let's do another one. 3 plus sec x is equal to 5. Now, sec may be a reciprocal ratio, but before we can start changing it into cos, we need to make sure that the trigonometric ratio is the only term on the left-hand side of the equal sign. And that means we need to move 3 to the other side. So on the left, we now have sec x is equal to 5 minus 3, which leaves us with 2. Now we can change sec into its reciprocal ratio, and we get 1 over cos x is equal to 2. Let's move cos x out of the denominator of the fraction. So on the left, we now have 1 is equal to 2 multiplied by cos x. And now we can get cos x by itself by dividing both sides by 2. So on the left, we now have 1 over 2 is equal to cos x. And now we can solve for x. So let's move cos to the left-hand side, and we get cos the negative 1 multiplied by the bracket 1 over 2 is equal to x. Now let's get our calculator. We say shift cos in the bracket 1 divided by 2, close the bracket, is equal to 60. So in this case, x is equal to 60 degrees. Let's do another one. Sine 2x plus 5 is equal to 5,83. Our first step is to move the 5 to the right-hand side of the equation. So on the left, we now have sine 2x is equal to 5,83 minus 5 leaves us with 0,83. Now our trigonometric ratio is by itself, which means now we can get x by itself. So let's move sine to the right-hand side, and we're going to have 2x is equal to sine to the negative 1 multiplied by 0,83. Let's get our calculator out. We say shift sine multiplied by 0,83, close the bracket, is equal to 56,098 degrees. So we can make a note of this, and we can say 2x is equal to, let's round our angle to 2 decimal places, and we get 56,1 degrees. Now, this is the value for 2x, but we just want x, so we still need to divide both sides by 2. On the left, we're left with x is equal to, now we can take our calculator, and we can take our answer, divide by 2, and we get 28,049 degrees, round off to 2 decimal places, and we get 28,05 degrees. This is our value for x. Let's do one last example. 2 sine 3x plus 1 is equal to 2,6. Now, 2 sine 3x is one term, and to get it by itself, we have to subtract this 1 from each side. So on the left, we have 2 sine 3x is equal to 2,6 minus 1, which leaves us with 1,6. Our next step is to get sine 3x by itself. And to do this, we divide both sides by this 2 over here. So on the left, we now have sine 3x is equal to 1,6 divided by 2, leaves us with 0,8. Now we can get 3x by itself, and we're going to move sine to the right-hand side of the equal sign. So now we have 3x is equal to sine to the negative 1 multiplied by 0,8. Now we can open our calculator, and we say shift sine 0,8, close the bracket, is equal to 53,13 degrees. And we can make a note of it over here. But this is the value for 3x. We don't want 3x, we want x. And to get x by itself, we divide by 3, and we're left with x. So now we have to divide our angle by 3 as well. So take our calculator, and we're going to take our answer divided by 3 is equal to 17,71 degrees. And this is our value for x.